Welcome everyone. Today, I'm excited to introduce you to our 100-liter brewing equipment. This is a 2-vessel brewhouse with a hot liquor tank, a mash lauter tun, and a kettle whirlpool tank. All controlled by a PID panel. Underneath the brewhouse, you can see the pipelines, valves, and a small heat exchanger. We are currently in the mashing phase. You can see the grist in the tank, which includes 15 kilograms of barley malt and 7 kilograms of wheat for a white beer recipe experiment. The mashing temperature is 66 Celsius degrees, and it will last about 1.5 hours. Next is the wort filtration, which we call lauter. But before we transfer the wort into the kettle whirlpool tank, we need to recirculate it with a Vorlauf process. This process clarifies the wort, and we can observe it through the sight glass. Once the wort reaches the required clarity, it will be transferred to the kettle whirlpool tank and boiled. The lautering process lasts over an hour, and we take the first wort sample for testing. We add hot sparge water on top of the grain bed to rinse any leftover sugar molecules and prevent air exposure. Before boiling, make sure that the liquid in the kettle is more than 100 liters, with consideration for evaporation. After the lautering process, we can remove the spent grain. For the small brewing equipment, we do this manually. But the larger brewing systems are equipped with a raking device inside the lauter tun. Finally, any remaining grain is removed by CIP cleaning. We also add hops several times during the boiling process, usually in 3 separate additions. The first 2 are for bittering, while the final addition is for aroma. After boiling, the wort is pumped back into the tank for whirlpooling, which separates the hot trub from the wort. Note that the pump doesn't run the entire whirlpool process. Instead, we turn it on for 5 minutes and off, let the wort rest to heat a trub. When we do run the pump, we use either the maximal or a large rotation speed on the VFD. Once the boiling process is complete, the wort is cooled with a single-stage heat exchanger, exchanging heat with cold water. The wort will be cooled from 90 Celsius degree to 20 Celsius degree. We make an O2 aeration to the cold wort to promote yeast propagation. And observe the aeration process and the clarity of wort through the sight glass in the heat exchanger. The final step is to transfer the wort to the fermenter for further processing.